Oke, sebelum saya mulai, kita berdoa dulu. Alangkah lebih baiknya agar ilmu kita pelajari berkah. Berdoa, saya persilakan. Amin. Oke. Okay, we still have another 4 weeks. So today we'll discuss about Markov chain analysis, and next week about the querying waiting line analysis, about the querying analysis, and we also learned about the Monte Carlo simulation. And at the end, you guys have to present the final paper. Okay. Okay, today's class is about Markov analysis. So the learning objective of this class is about how you can analysis the Markov chains. It's about how we can measure the probability in statistics. So you can compute long terms of steady states conditions in state space, and also how to calculate the transitions probabilities in statistics. So it's also necessary if you're talking about how we can maximize our business later. So you have to know how to calculate the steady state or state space in Markov analysis. Also, you can understand the use of observing state analysis and predicting future states or conditions, and also put Markov analysis into practice for the operations of machines. So you can analyze the issues of logistics research. Also recognize equilibrium conditions and steady state probabilities. So it's all about calculating the probabilities. And in the end, understand the use of observing states and the fundamental metrics. So it is about how we can calculate the state space, states, and state probabilities, calculate about the matrix of transition probabilities. We can predicting future market shares, performing market analysis of machine operation, calculate the equilibrium condition, and also we can also calculate the state space and the fundamental metric itself by a receivable application. So introductions. What is the definitions of Markov analysis? So Markov analysis is about we calculate the probabilities, because in statistics we have to know the probabilities by feature. So we can get the probabilities from the 0 until 1. So the scale of probabilities not more than 1. So that's why the Markov analysis is very popular. The applications in business and logistic areas. So we can assume the system starts in an initial state or condition. That's why if you're talking about the Markov chain, we're talking about how to different every state space in every conditions and every probability. So how we can measure the conditions, how can we measure the probability? Of course, we can get the information from the matrix of transition probabilities. So these terms in statistics, you can get the information, the different state of different conditions in different categories. And in the end, we can record basic matrix manipulations. So it is about the basic algebra elementary. So you, if you forget about that, I suggest you to learn again about the calculus. So the basic is about we can make the matrix. We will calculate the eigenvalues for every state space. So the discussion limited to Markov probabilities that follow for assumption. So these the 4 essential assumptions in Markov chain. First, there are limited or finite number of possible states, because there's not many state space we can get into it too if you want to make the predictions by future. So there's limited or finite number of possible states. Second, the assumption is that probability of changing states remains the same over time. So it's called of independent. So every state or every condition should be independent. And we can predict any future state from the previous state and the matrix of transition probabilities. That's why if we want to predict by next year ahead, next week ahead, we have to concerns about our big data, our past data. So our past data influence the result of our future transitions or future predictions. That's why we can using this state space to make the predictions, the transition probabilities. Also, the last assumption is the size and makeup of the systems do not change during the analysis. So it is also called about independent. So every stat should be independent. So we can change the size to the system by performing the analysis. States are used to identify of all possible conditions of a process of system. So if you're talking about how the different about every state or every space is also different. So it also depends on condition. And the Markov analysis, some states are both collectively exhaustive and mutually exclusive. So that's why if we using the Markov analysis, we also assume that every state is independent, but it's also probably connected to each other. So it's mutually exclusive. And the next step is to determine the probability that the system is this state. That's why, for example, if we have 4 states, for example, risk, no risk, high risk, or moderate, so we can measure the different about every state, different of about conditions. So how the probability transitions in every state space. Wait, I'll show you first my paper to be more clearly understand. So that's what I'm talking about. For example, I have 3 state space from the no risk, medium risk, and moderate. So every state space we can make the probability, the transition of the difference. For example, how is the transition from the medium to the risk? So I can get the probability 0.1. So how the transitions from the no risk, from the medium risk to no risk is 0.192. So no risk to medium risk from this probability. Also, how I want to get information from the medium risk to moderate, so I can get this transition probability. So it means the probability change from the state medium risk to moderate is very significant than the others. So this is the idea of using the Markov state space. So we back to PPT. So this I'm talking about if we're using the state space. So we can get information from the factor of state probabilities. So we have VI. So VI means the factor of state probabilities for period I. So we can get the information from the probability state 1, state 2, state 3 until state n. It depends how many variables you want to analyze to. So every variable, every state, it depends on your variable independent. So n refers to number of states. V1 until Vn is talking about the probability of being in state 1 that I'm talking about in last slide. We can measure the different transitions of every condition. So we can calculate by probability transition. So in case with time, it's possible to know with complete certainty in which state. That's why if we're talking about the probability, it start from the 0 until 1. So probability will not more than 1. So these are the values of the probability. So P1 is replace of the factor of state for the machine in period 1, our state space. And the P1 equals to 1, it means the probability of being in the first state. So that's why if we start measure the probability, the state 1 should be 1. And the last is about P2, probability of being in the second state. So these are the basic criteria how to measure the states in probabilities. But in most cases, you are dealing with more than one item. So how if you have 2 variables, how if you have 3 variables, or if you're talking about the big data, it's about 1,000 variables. So stat space can be dealing with that if we have more than 1,000 variables probably. So for example, about the groceries, for example, so the question is stats for people in a small town with 3 grocery stores. So this is our information. So we have 100,000 people shop at the 3 groceries during any given month. 40,000 may be shopping at the American food. So this is our condition 1. 30,000 may be shopping at the food mart. So this is our condition 2. And our state 3 or our last condition is about 30,000 may be shopping at last foods. So this is our information. So you can measure the probability different of every step. So how the probability is step 1 to step 2, step 2 to step 3, or step 3 to step 1. So we can analyze that information. So for example, because reverse on the question, so we have this information. Step 1, we have the 40%. Step 2, we have the 30%, and step 3, we have 30%. So if you substitute from the step 1 until step 3, we have 100%. So that's why if you calculate by Excel later in practicum, if the value is not close to the 100%, because the probability should be 0 until 100%, so maybe you wrong analysis. So you have to make sure the probability will be close to 100%. So we can make the probabilities by every step. Step 1, step 2, and step 3. Step 1, we have 0.4. Step 2, we have 0.3. And we are in the last step, we have 0.3. So P1 refers to a factor of start probabilities for the 3 grocery stores for period 1. So this is our information. We can analyze the every step space. So refers on this information. 0.4 is refers for the probability the persons will shop at the American food step 1 until step 3. So later, if you have maybe 10 or thousands step, you can measures of every probability or every conditions in every state space. So the probabilities of the factor states represent the market shares, or it represents depends on the independent variable. So later if you have homework, so the conditions or state space, it depends on your dependent variable. So for example, because we have 3 independent variables here about the 3 groceries, so the state space should reference the market shares information. And the management will be interested in how the market share changes over time. So we can analyze by this transition probability of every state space. So for example, because we have 3 conditions from the store 1, store 2, and store 3, we can measure the every conditions of probability. For example, because the state space should be 1, we can get the probability 0.8. So if you're talking about the step 2 or step 3, it depends the information of probability. So you can measure like that. So we have 0.1 and 0.1. So if you summarize this information, it should be 1. So same with the others information with the SEM 2 and SEM 3. So we can analyze the different state of different state and different conditions in Markov chain analysis. So this 3 diagram for 0 months would be get very large. It depends on your this question. And also we can easier to use the matrix of transition probabilities by using the Markov chain. And a transition probability is the probability of moving from one particular state to another particular state. That's why every different condition we can analyze different probability. So this is the goals of using the Markov chain. That's why if talking about how to measure the different condition, for example, from the moderate status to medium risk status, we can analyze how much the probability, the difference of state from one location, one state to second step, and second step to the last step. So this is the idea of the Markov chain. So the matrix of transition probabilities, this is the basic information in the Markov chain. We can analyze by transition of probability allows us to get from a current state for a future state. That's why if we want to make the predictions by next step ahead or state or next state space, we can get information from our last state space or last condition. So this is our basic information. We have PIG. PIG means the conditional probability of going in the state J. So this last information in the state J in the future given the current state of I. So we have the probability by conditions in the state J in the future given the current state of I. So the past information of the past data is also essential if we want to predict our state or predict our future. So for example, I have this mathematical mathematical symbols, P12. So P12 is the probability of being in step 2, in the future, given the events was in step 1. So we want to predict the step 2 with informations in step 1. So this is how you read this symbol mathematical. So this the idea of the Markov chain is about the matrix. So you can measure the transition of the probabilities by every values in matrix. For example, P is our matrix transition probabilities. So every individual start the P11 until the P1 end until so we have also PM1 until PMN. So individual of PIG, so if they are determined empirically. That's why if we're talking about the probability, each row will sum to 1. So later, if you calculate by Excel later, if you get the answers, it's not close to 1, probably it's wrong. So I expand again, the informations of the probabilities that from 0 until 1. So if we summarize every row, so the value will be close to 1. So by the current example, with the grocery store example, we can using the historical data to develop the matrix transitions. For example, we have the point X equals to P11. So P11 is probability in being step 1 after being in step 1 in the predicting period. So we have the information. So but P12 means the probability of being in step 2 after being in step 1 in the preceding period. So we want to predict the step 2 with the information in the P1. And also we have the information P13. This one, P13 is the probability of being in step 3 after being in step 1 in the preceding period. So you can get information by using this information. So if we summarize, the probability should be 1. So this is our example of transition probabilities by using the grocery store example. So we have row 2. We saw our row 1. We can analyze the row 2. Row 2 also you can get information how the difference of the every probability in every state by using the current or the previous state space. So we can using the row 2 until row 3. It depends how many independent variables, how many state space you want to analyze. So later, if you have the 10 variables, so your matrix should be 10 by 10, the matrix. So it depends how large your matrix. So it also depends the research question later. So how if you want to predict for future market shares, we can using one of the purpose of Markov analysis to predict this information. So the goals of Markov analysis of Markov chains, we can use these methods to predict our future or predict the probability. Also, use the vector of state probabilities and the matrix of transition probabilities to determine. So we also can determine the state probabilities at future date. So this is the information of the Markov market shares by using the Markov analysis. Also, it allows the computation of the probability that a person will be at one of the grocery stores in the future. So later in the probably week 13, we will talking about the another computational by using the Markov analysis, so Markov chain. So we can also using that information to measure our computation. So if you interest to learn more detail about the data science or about machine learning, it's about how we can get the best framework or the best methods to measure the computations until we get a high accuracy. So it depends what type of computations you will measure every probability. So it is different. So the last point, because the probability is equal to market share is equal, so it is possible to determine the future market shares of the grocery stores. That's why if you're talking about the every state space, it should be independent. So these are the basic assumptions in the Markov chain. So when the current period is the 0, how if the current period is 0, we can analyze the state probabilities for the next period 1 with this information. If the information is the 0, we can using the by V0P. So this is our information. But for the any period of n, every any period, if we have another period, maybe 10 period, or if talking about the 1 year analysis, That's why we have 300, more than 300. We can compute the state probabilities for period n plus 1. That's why if we have different number of the state space, if you have different number of the data, it depends on many independent variable. So n is refers how many step, how many period you want to predict. So we can using by v n plus 1. So this information v n p. So this is the information if we want to compute the state probabilities. So it is the how we analyze the question by using the future market shares. So we can using the computational for the next period shares by this information. We have P1, so we calculate by P1 by P1P. So if you still remember the information of information is 0.4, 0.3, 0.3. This is the basic information. So because the transition should be 1. So this is our transition matrix. So you have to keep in mind the base information for every P or every state space and every on the next state space. So you can calculate like this. So 0.4 multiplied by 0.8 plus 0.3 multiplied by 0.1 plus 0.3 multiplied by 0.2. Oh, sorry, like this. 0.4 like this to this, like this to this. So 0.4 multiplied by 0.8, 0.3 multiplied by 1, and 0.3 multiplied by 2. So you have to calculate it like this, that, like this, and like this. You can multiply and get these informations for every state space in the next state ahead. So we have informations 0.41, 0.31, and 0.28. So these are our state space conditions in the second step. So because this is our P1. So we can analyze the market share for milk and food because these are research questions, and the food mart have the increase and the market shares for Atlas Food has decreased. So we can determine whether this will continue by looking at the state probabilities will be in the future. That's why the 4-2 time period for now we can using by P2. So this the previous step using P1 we can using by P2. P2 can get by equals to P1 P. So if you want to measure the P2, you have to measure the P1P for the next 2 period from now. So because the basic information about P1 is the P0P, the basic information, we can extend the P2 conditions by using like this. So we have P2, P1, P. So P1, P0, this is our first step of P multiplied by P. So we can get the information of the P0 PP, or we can square this information. That's why if you're talking about how to measure the P2, we can get by like this, P0 P squared. And we can generalize again this equation like this. It depends how many steps you will analysis. So we have the P1, Pn refers to P0 P power n. So it depends how many steps you want to predict the information. If you want to predict the future market shares, so you can using this information. So locations of the leader, American and Food Mart will continue to gain market shares, and Atlas will continue to lose its base address in the terms of equilibrium or steady state condition. So the last information is how if the Tolsky Works has recorded the operations of the his milling machine for several years. So it different question. So over the past 2 years, 80% of the time of the milling machine functioned correctly for the current month if it had functioned correctly during the preceding month. So this is another information. Also, we have information 19% of the time of the machine remained incorrectly adjust if it had been incorrectly adjust in the preceding month. And that's information 10% of the time the machine operated correctly in a given month when it had been operating incorrectly the previous month. So we can get this information. 0.8, 0.9, and 0.1. 0.8, 0.2, 0.1, and 0.9. So this is our information. P11 or 0.8 is the information or probability that the machine will be correctly functioning this month given it was correctly functioning by last month. So this information P11 refers to every machine correctly. 0.2 because you have to get the probability 1. So this state should be 0.2. So 0.2, it means the not be correctly the functioning. And the P21 refers to if the machine will be correctly functioning and it was not correctly functioning by last month. So that's our information. Also, we can get information of the P22 is 0.9. So P99 refers to if the machine will not be correctly functioning, but it was not correctly functioning last month. So these are our conditions of every transition matrix probabilities by this information. So later, if you have this kind of questions, you have to know how put that information to the matrix probabilities. So the Trotsky works. What is the probability that the machines will functioning correctly 1 and 2 months from now? So we can analyze like this. We have the V1. V1 is the information of the V0P. This is our information 1, 2. So you can measure the multiply by 1, multiply by 0.8, and the 0 multiply by 0.1, and the 1 multiply by 0.2 plus 0 and 0.9. So these are our information. We have 0.8 and 0.2. So this is the information, the questions. How is the probability that machine will be functioning correctly in 1 and 2 months from now? So this is the probability. So this is the answer. So it's quite easy. So another question, what is the probability that the machine will be functioning correctly 1 and 2 months from now? So because we can get these informations, 0.1. So this is our state condition. We want to analyze next step, next text condition. So we can put the information of the P1, this information 0.8 and 0.2. So you can analyze like that step. So we can get this probability. So this is the probability the machine will be functioning correctly 1 and 2 months from now. So we can get the information is the 0.66 and a 0.34. So this is our last the probability transition. So if you're talking about the equilibrium conditions in the Markov analysis, it's easy because that's I said about if you're talking about the probabilities, it start from the 0 until 1. So the probabilities not will be more than 1 or not be less than 0. So it is the information for the probability. So if we're talking about the equilibrium shares of the market values or probabilities generally exist. That's why we can using the steady state or state space by using the equilibrium probabilities. So every state, every conditions, we can make the probabilities. So the equilibrium conditions exist if the state probabilities do not change after a large number of the period. So you're still talking about independent. And the equilibrium, the state probabilities for next period equal the state probabilities for the current period. And the last information is the equilibrium state probabilities can be computed by repeating Markov analysis for a large number of periods. So you can make the looping later by if you want to using by data analysis or big data, we can set by computational so it can looping automatically. So for example, this is the informations of the state probabilities for the machines. Example for 15 period. So this is our information with the 15 period. So this is our information, state 1 and state 2. So for example, state 1, we have 1 probability and 0 probability in state 2. Also in the period 1, we have 0.8, 0.2 until we have the period 15. We have the 0.33 and we have 0.66. So this information of state probabilities for the machine by 15 periods. So if you using the equilibrium condition, there's the information. The information should be if we have the phi next period will be equals by phi this period p. So this is the basic information. Or phi n plus 1 or phi by next step forecasting will be equals by phi n p. So this is also our information. And the third condition, phi n plus 1 will be same as the phi n. So this is the information of the equilibrium. So that the equilibrium, you can extend the equations by phi n plus 1, which is phi np and phi n. And this is our last equilibrium conditions. We have phi p. That's why if you're talking about the equilibrium conditions, we can get the information by next period depends by current period or now period. Yeah, this is how we using the equilibrium condition. So this is the information of the last question about the Trotsky machine. We can analyze by Vp. So we have the V1, V2, because we have the state 1 or the current conditions, V1, V2. So this is our transition matrix, 0.8, 0.2, 0.1, 0.9. So you can multiplications by these informations by 0.1, 0.8, 0.2, 0.1, 0.1, V1, 0.2, P2, 0.9. So it's quite easy using this information. And you can get the every conditions of by using the informations. For example, the first and constant terms on the left side. So this are our conditions. And the phi and the 2 are equal to the first terms on the right side. So it should be equal. And the state probabilities sum to 1. So we have to sum the probabilities P1, P2, plus until Pn, how many state or many conditions with the state space Markov chain. And if we summarize this information, should be 1. So about the four Trotsky machines questions, we can multiply by V1 plus V2. So we can get probability close to 1. So by using the informations, we can decide to solving that question. We have the P2, we have this probability 0.2 plus 0.9. So this will be more than 1, because if you summarize, the probabilities will be 1.1. It's wrong. So through the rearrangement, the substitutions, we have to change the substitutions by 0.1 P2 equals to 0.2 P1. So we can calculate. So because this should be 0.2 divided by 0.1, so we can get the V1 is the 2. So V1 plus V2 is the 1, and we put that information. V1 plus 2 V1 should be 1. So we have V1 is the 1 by 3, and P2 is the 2 by 3. So we have this transition matrix. We have the we have 0.3 for the current conditions of the V1, and we have the 0.6 with the information of the V2. So this is how we analyze if we have two different equations by using equilibrium. And it's about how we can observing state and the fundamental matrix by Markov chain. For example, if you're talking about the quants visible example, by example so far assume it's possible to go from one state to another. So for example, if these have the 4 step, we have the V1 paid, V2 bad debt, V3 is the overdue less than 1 month, and the V4 is the overdue between 1 and 3 months. So the last example, if we have 3 conditions, but in this example, if we have the 4 state condition, it's also easy. So for example, this is our information by the table by using matrix of transition probability. So this is our information. You can change this information as the matrix. So we have the P. This row should be paid, bad debt, less than 1 month, and 1 to 3 months. So this is our information, the matrix transition probabilities. So how to obtain the fundamental matrix? So you can analyze like this. So you can separate every information. For example, I is refers by identity matrix. So because the identity, that's why the diagonal should be 1. If I was talking about the identity matrix. And as for 0 is the matrix with all of the zeros data or zeros information. And A and B, A is refers of our informations by the research question. So we have these informations A and B. And I repeat again, we have the P matrix. P matrix reverse the whole of the informations in the research question. I refers of the identity matrix. If we're talking about identity matrix, the diagonal is 1. So this the information of identity matrix. The 0 it refers the non-information in the research question. And A and B it refers of our information in the research question. So we can using the we can analyze the observing state by analyzed by that matrix by using F. For example, F is information of fundamental matrix. That's why we can using by identity matrix, is our identity minus B. So you can using the inverse by matrix, we can do inverse. So if we inverse the information, so you can get this matrix of F. We have the point A minus point 2, minus point 3, and point 8. So you have to remember the inverse, how we inverse the information. For example, we have the A, B, C, D, and it should be A, B, C, D by inverse. So you have to analyze D per R, minus B divided by R, minus C divided by R, and A divided by R. So you have to analyze how to measure the R by AD minus BC. So if you forget how to do this, you have to read again the basic calculus or basic the algebra linear elementary. And how to find the matrix F? We can compute by these equations, R, AD minus BC. So you can analyze by like this, AD, 0.8, BC, minus BC, minus 0.2, multiplied by minus 0.3. So you will get information. So the matrix of the F is the 0.58. So by using the information, that's why if you want to inverse, we have to find first the R. So by using the information, we can divide it by this R information. So that's why we have the 0.8 divided by 0.58 until number informations. That's why this our F information is about 0.138, 0.3, 0.5, and 138. This is our identity matrix. That's why the values should be 1, or the values should be similar. That's why if we divide it by these informations, this value should be 1. So this in the identity matrix. And by using that information, remember, because we have the full state space here, we can using the matrix FA to answer questions such as how much of the debt in the last than 1 month category will be paid back and how much will become bad debt. That's why the informations we have the 4 condition. So example later, if you have more than 4 conditions, so you can put the MN here. So in MN is refers how much amount in the end state or category in our state space condition. So for example, if we assume there is $2,000 in the less than 1 month category and $5,000 in the 1 to 3 months category, M would be this information. We have the M, this information, and we can measure how much the amount paid and the amount in debts by using the MVA. So since it's easy, you can calculate by multiply by this information to this information and this information to this information. That's why if you calculate manually later, you will get the information. So this information is addressed the question, the number of the amount paid and the amount in the bad debts. So this is our information. It's easy. So out of the total of the $7,000 and $6,000 will be evenly be paid, and $700 will be end up as the bad debt. So this information of our research question. So it's easy, isn't it? So I will discuss more detail about how later you can analyze the Markov analysis. Later I will send the paper to you. So here are the mathematical things. Wait. So the idea of the Markov chains, if we have the S informations of the R subset, for example, if you're talking about the how many state space, how many, if you want to measure the risks or depth of different patterns of the risks, we have to know how the subset of every problem. That's why if we are talking about the Markov chain, you're talking about the stochastic process, because it depends, our information depends by our past data and be influenced by our future data. So it could be the stochastic process. For example, if I have the X variable here, so T depends on the many step I want to forecast. For example, tomorrow or the day after tomorrow. So it depends how many steps ahead you have that. So mathematically in the state space, you have to using by omega. So if you want to analyze for every state space, it mathematically we using by the symbol omega. So every t is called be our random variable or our independent variable. So for example, if you have the 4 variable, you have 1,000 variable, so you have the x thousands for random variable. So how to analyze the Markov chain? By the skip time from the t every time 1 until 2. So we can calculate it like this. P xt plus 1 is j information, xt1, xt minus 1. And we can get information of the it minus 1, x1, and I1. So this the basic information. To calculate the Markov chain, start from the one condition until last condition. It's easy. So how if we want to generate that, we can use it like this: p xt plus 1, this is our information, and the xt is 1. So this is the equation how if we want to using the Markov chain by predict. So this is the information that because our data should be homogeneous, that's why every conditional distribution for any state xt plus 1, for example, tomorrow or the day after tomorrow, should be free or should be independent. That's why every state or every condition should be independent. So it cannot be influenced by each other. So every state, every condition should be independent. So this is our information. We have x1, x2 until xt minus 1. So this is our information of the state space or every condition in Markov chain. That's why this information also called as the Markov properties. Markov properties of every chain. That's why the assumptions of the Markov chain is homogeneous. That's why we can analyze by Markov chain by using the xt, t, start from 1 until 2. That's why every state is homogeneous. Then you can using these informations to predict every Pij or every condition with the today, with today tomorrow, or tomorrow with the day after tomorrow. So you can analyze every condition or every state space or every homogeneous variables in our data set. So later you can read this information because the Markov chains is very applicable if you want to using the risks, if you have to determine every probabilities or every condition or every state space. So it is the very basic informations in the Markov chain. That's why if you're talking about the Markov chain, it's all about the probability transition. So by last slide, I already tell you about how we can get information by probability transitions. We can get the matrix P. So this information start the P11, Pin, it depends how many variables here, row. And you can have the column Pn1 until Pnn. So this is our best information of the P probability transition. Here, for example, how if we can analyze change time by time. So we can using by determination. T is the probability of the IT, I. So this our state change by time. For example, so by using criteria, because we can start from first step should be measured as the 0 because this is our first information. So the Markov properties for every order of the real numbers start from 0, less than T0, less than T1, and less until our last prediction or our last state space. That's why we can extend the equations by like this. The probability of the I, Tn plus 1, we have the information IT0 until Itn. So I can extend the equations by like this. We can using the probability by current informations of Itn plus 1 with the conditions of the information of the Tn. So this is how we can measure the probability transition. Later you have to read it manually, how to understanding the probability of transitions, because the current book, the author is not mentioned how to prove it manually, how prove it consistently by using Markov chain analysis. You can read my paper. So for example is because I have 3 conditions. similar by last question. If you still remember, we have V1, we have V2, and we have V3. So I already calculate manually. You can copy paste if you're interested to bring this topic as your final thesis. I already prove it manually. You can copy it. So we can using by like this as the calculate by VP. So VP, it depends how many state number of every condition. That's, for example, because in this paper I only have three state space, V1, V2, V3. So how to measure the V1? So we can using the by V1, P11 plus V2, P21, and the V3, P31. So this is how we measure the V1. And also you can analyze the V2 and V3 with the same condition. V3, V1, P13 plus V2, P23 plus V2, P33 minus 1. So this is the example of using the V3. Then we can get the transition matrix at every condition. That's why if we have the identity matrix, the information should be 1. So we have the V11 minus 1, V2, V31. We have the V12, V22 minus 1, V32, and we have the V13, V23, V33 minus 1. So this information of the transition matrix. And I already prove it manually, so you can see how every conditions in every Markov conditions in the transition matrix. So we can measure how if we have three state space, if we substitute by V1, V2, V3, the information should be 1, our probability. So these conditions of the V1, this condition of the V2, and this information of the V3. So I already prove it manually to you. And the information of the P, S, R key, I already explained it manually. So you can copy, paste, or you can see the data information. How to measure the P, Q, R, and S every state space. So this I'm talking about. For example, I have, I want to predict by 7 days ahead. That's why the current conditions start from the 1 until 2. I can get information. These informations 1 minus P1. So this the transition start from the 1 until 2, and 2, 3 is the 1 minus P2 until the last prediction or the last information. I can analyze the difference by 1 minus P6. P6 means the information from the 6 until 7. So if I substitute the information should be 1. So this is the idea of the Markov chain analysis. So later, the Markov analysis, you can get to solve the information, the transition, how the chain with the moderate to medium risk and medium risk to no risk. If you're talking about the climate change, so how if talking about the debt or the financial issue, you can analyze by SAM's criteria like this. So the basic informations of the line of the probability transitions is how to measure every condition or every state space condition. So this the basic idea to understanding the probability and the Markov chain. So you can see I can measure how many probability. For example, by next month, no risk. So I can get the information. By next month, no risk to medium risk, how much information. So you can get this information like this by get the information of the transition probability. Yeah, this is the proving of the mathematical theory. Maybe you can read it later. I'll forward this to you. Because no one author proof the mathematically how consistent every state space condition. Any question? Because because it is so easy how to understanding the Markov chain. So this give by, for example, by the step 1, if we have the three condition, and last question, how if we have 4 condition. So this is quite easy how to understanding every step or every condition. Any question?